We think we understand where trees originate. We've witnessed it countless times. Plant a seed, water it, wait, and something green emerges and grows upward. It seems straightforward. Trees grow from the ground. Everyone accepts this as fact. But here's what deserves closer examination. A mature oak can weigh around 10,000 pounds. Consider that reality for a moment. Thousands of pounds of wood, bark, roots, and branches that didn't exist 100 years ago now exist. The legitimate question becomes, where did all that mass actually come from? Not poetically or vaguely, but physically, where did those 10,000 pounds of material originate? The intuitive answer points to soil. Roots penetrate deep, absorb materials, and those materials transform into tree. It makes sense. So let's test this assumption. A 17th century scientist named Jan Baptist van Helmont conducted an experiment that reveals something surprising. He took a 5-pound willow sapling and planted it in 200 pounds of dried soil. After 5 years of watering and growth, the tree weighed 169 pounds, a gain of 164 pounds. When he dried and weighed the soil again, it had lost less than 2 ounces. The tree gained 164 pounds while the soil barely changed. Where did that remaining 163 pounds come from, if not from the ground? This is where most people stop thinking and move forward, assuming some technical explanation exists that they don't understand. But pause here. What just occurred is genuinely extraordinary. 164 pounds of solid matter appeared from essentially nowhere, and the explanation remains elusive. This represents a significant gap in understanding how the physical world functions. The answer transforms how you think about trees, air, and matter itself. Water seems like the next logical source. Trees absorb enormous quantities. A large oak draws up roughly 100 gallons on a hot day. Yet water is H2O, 2 hydrogen atoms and 1 oxygen atom. When trees process water, they extract hydrogen while releasing oxygen back into the atmosphere. Hydrogen is the lightest element. You'd need astronomical amounts to account for significant mass. More critically, wood isn't composed of hydrogen, it's made of carbon. Carbon comprises roughly half the dry weight of any tree and forms the backbone of every organic structure. Here's the problem. Soil contains insufficient carbon and water contains even less. While roots do absorb minerals like nitrogen, phosphorus, and potassium, these minerals constitute only 1 to 2% of a tree's total dry mass. The overwhelming majority of what a tree is made from cannot be explained by anything emerging from the ground. The mathematics doesn't work. You're left with something unsettling. A 10,000-pound object grew from a tiny seed, yet you cannot account for where the mass originated. Not from soil, not from water, not from anything visible entering the ground. The answer lies elsewhere entirely, somewhere most people never consider. The mass comes from air itself, not soil, not water, nothing tangible you can hold or see descending into the earth. The vast majority of a tree's physical substance comes from an invisible gas in the atmosphere, carbon dioxide, the same substance you exhale, the gas that comprises 0.04% of the air around you. A 10,000-pound oak is, in the most literal sense, solidified air. When Van Helmont couldn't locate the missing mass, the answer floated directly in front of him the entire time, invisible to his eyes. Here's what's actually happening. Trees extract carbon dioxide from the atmosphere through microscopic pores on their leaves called stomata. The CO2 enters, the tree disassembles it, strips out the carbon, and uses it as raw material for construction, chaining carbon atoms together into complex molecules. These molecules become glucose, cellulose, lignin, the rigid fibers that make wood what it is. The leftover oxygen returns to the atmosphere, which is your oxygen source. The tree essentially operates a disassembly line on thin air, pulling invisible molecules apart, retaining the carbon and releasing the oxygen back. That carbon becomes wood, solid, dense, physical wood you can touch, cut, and burn. This isn't metaphorical. It's the actual molecular mechanism. Consider the implications. Every wooden plank ever built started as a gas. Every table, ship, forest, and piece of paper you've touched was once invisible CO2 drifting through the sky. Trees are mechanisms that reach into the air, extract matter, and stack it into solid form using only sunlight as fuel. Now, let's examine how this process actually works. Most people remember the word photosynthesis from school, something about sunlight, chlorophyll, and oxygen, but never understand what's truly occurring. What happens is one of the most extraordinary physical processes in existence. Sunlight strikes a leaf. But sunlight isn't merely warmth or brightness. It's electromagnetic radiation, oscillating fields traveling at 300 million meters per second. It's the same fundamental force that holds atoms together, the force behind magnets and electricity. When these electromagnetic waves hit a chlorophyll molecule within a leaf, something remarkable occurs. An electron in the chlorophyll absorbs the light's energy and jumps to a higher energy state. This energized electron travels along a chain of molecules, and during this journey, it powers the construction of ATP, the energy currency cells use to perform work. This is the light reaction, energy captured from electromagnetic radiation and stored chemically. The plant then uses this stored energy to do something almost impossible. It takes CO2, a remarkably stable molecule with no inclination to break apart, and forces it open. It extracts the carbon and uses it to build glucose, a simple sugar. This glucose is the first solid thing in the entire process. The first moment when invisible atmospheric gas becomes an actual physical molecule the tree can use. Next, the tree does something even more impressive. It chains thousands of glucose molecules into long strands called cellulose, the primary structural material in plant cell walls, and into lignin, which fills the spaces between cells and gives wood its hardness and strength. These are what wood actually is. The chemical bonds holding all these molecules together, the bonds between every carbon atom and every cellulose strand in every tree on Earth, are electromagnetic bonds. The same force, always the same force. Sunlight, electromagnetic radiation, strikes a leaf. Energy gets captured and used to forge electromagnetic bonds between carbon atoms pulled from the air. These bonds construct glucose. Glucose builds cellulose. Cellulose builds wood. Electromagnetic energy becomes solid matter. And this process extends far beyond trees. You consume food composed of plants or animals that ate plants, or animals that ate animals that ate plants. Every calorie you've ever consumed traces back to something that grew by pulling carbon from the air. This means the carbon in your muscles, bones, brain, the carbon in every cell in your body right now, was atmospheric CO2 not long ago. You aren't made of earth or water. You're made of rearranged air, stitched together by electromagnetic bonds and powered by ancient sunlight. Every carbon atom in your body has a history. It floated as CO2. A plant extracted it and built it into glucose. Something ate that plant, something else ate that, and eventually the carbon reached your food and your body, forming the molecules that constitute you. Before existing in the atmosphere, that carbon was part of another organism that died and decomposed, releasing it as CO2 to cycle through again. Carbon has been moving through living things in the atmosphere for billions of years. You're a temporary arrangement of atoms that have been part of countless other things before and will be countless other things after. That's chemistry, not philosophy. When you truly understand what's happening, looking at a tree becomes more meaningful, not less. When you see an oak now, you're not seeing dirt that somehow stood up and grew bark. You're seeing hundreds of years of sunlight made solid. You're seeing electromagnetic energy captured from a star 93 million miles away, used to forge bonds between carbon atoms pulled from thin air, stacked atom by atom into something you can climb and shelter under. The tree doesn't draw from the earth. It draws from the sky, from the sun, from the air itself. And you, standing beside it, are the same process operating differently. Same mechanism. Sunlight captured, carbon bonded, matter built.